For this experiment, you will need 2 large buckets, clear plastic tubing, measuring tape, a stopwatch or smartphone, and 100, 250, and 1000 milliliter graduated cylinders. Before you start, be sure to measure the inside diameter of your tube, the length of your tube, the inside diameter of the bucket you will be siphoning from, the height of that same bucket, the height of your large graduated cylinder, and the total change in height for your first trial. The first step of the experiment is to fill your bucket. Next, you coil your tube into the bucket. It is important to note that there should be no air bubbles in your tube, or the siphon will not work. Before you start siphoning, be sure to measure the height of the water in the bucket. Remove one end of the tube and begin siphoning. Do not start measuring volume or time until the water is flowing at a steady state. Record the volume obtained in the graduated cylinder. Be sure to dump all the water you used back into your bucket after each trial. Run 5 trials at 5 different bucket heights to ensure 5 different flow rates are measured.
To model the flow rate of your siphon, apply Bernoulli's equation to the system. Outline a clear explanation of any assumptions made in the application of Bernoulli's, and clearly identify the initial and final points of fluid flow presumed. Note that while you're performing 5 different trials of 5 different heights, how you choose to measure these heights to aid in final calculations is purely up to you. You will also perform a propagation of error analysis for the experimental determination of flow rate. With this analysis, you will choose the method of data collection that will give the lowest percent error in flow rate, the ultimate goal being less than or equal to 1%. The uncertainty in time can be determined by the time required to quickly start and stop your stopwatch, and the uncertainty in each graduated cylinder can be determined by taking 1/3 of its smallest increment of measurement. Please refer to the handout on propagation of error analysis provided by your instructor for a detailed derivation.
Congratulations, you have finished this experiment.